This is my reassessment for Standard 6. Try 2. The problem is asking about an object in outer space that has a mass of 150 kilograms and is acted on by a constant force, and it moved from a certain location to another location. The final speed was given, and we're trying to figure out what the speed of the object was at its initial location. The mass of the object is 150 kilograms. Position 1 is the vector 9, -22, and -6 meters, and it ends up at 15, -26, and -11 meters. The constant force that is acting upon the object is 300, 500, -200 newtons. And the final velocity is 8.4 meters per second. We're starting out with the work energy principle, and where the system is obviously the object. Work is equal to the change in energy, and in this case it's the change in kinetic energy, which is equal to force times the dot product of delta R. Delta R we get by subtracting the initial position from the final position, and that is 6 meters in the x direction, -4 in the y, and -5 in the z direction, meters. So we plug that back into our equation, which is the force vector dot product, the change in R, and the constant force is 300, 500, -200, dot product 6, -4, -5 meters. And for the dot product, we get 1800 plus -2000 plus 1000, and that gives us 800 joules. We know that work is equal to the change in kinetic energy, and that would be K2 minus K1, which is the final kinetic energy minus the initial kinetic energy. And in this problem, we are able to figure out the final kinetic energy. So rearranging the equation to get the initial kinetic energy, we have K2 minus work. And we know that the kinetic energy is equal to 1/2 mv squared. So the initial kinetic energy would be 1/2 mv1 squared equals to 1/2 mv2 squared minus work. And by algebra, we get that the initial velocity is equal to the square root of the final velocity squared minus 2 times the work over the mass. And plugging in our numbers here, which is 8.4 meters per second for the velocity squared, minus 2 times 800 joules over 150 kilograms. And that gives us our initial velocity of 7.74 meters per second.